Inside the Linux source code, there is a file called stable API nonsense. It is not a bug report. It is official documentation, written by a kernel maintainer, shipped with every copy of the kernel on Earth. Its purpose is to explain why Linux will never promise that a hardware driver written today will still work tomorrow. That decision is deliberate. It is defended in writing, and it is one of the 3 reasons the laptop you bought came with Windows on it. In the next 14 minutes, you will understand exactly why Linux runs almost every computer on the planet, except the one on your desk, and why the 2 places it did win look nothing like a normal PC. Start with the thing that decided it before any technical argument ever mattered. Almost nobody chooses an operating system. People buy a computer and use whatever is already on it. So the real competition was never Windows against Linux on the merits. It was a fight over what gets installed at the factory. Microsoft won that fight in 1988, and the mechanism has a name. It was called per-processor licensing. A computer manufacturer agreed to pay Microsoft a royalty for every machine of a given type it shipped, whether or not that machine had a Microsoft operating system on it. Read that again. The manufacturer paid for Windows on machines that did not have Windows. The effect on a competing operating system is total. If a manufacturer wanted to ship something else, it paid Microsoft anyway, then paid a second time for the alternative. Manufacturers who declined the arrangement lost discounts reported to reach 40%. The Department of Justice sued in August 1994. The consent decree signed that year explicitly banned per-processor licensing, but the practice ran for roughly 6 years first, and 6 years was enough. By the time it ended, Windows was the only operating system a normal person had ever seen on a store shelf. The pressure did not stop there. In November 1999, Judge Thomas Penfield Jackson issued 207 pages of findings of fact in the second antitrust case. He found that Microsoft held monopoly power in the market for Intel-compatible PC operating systems, that this position was protected by a high barrier to entry, and that Microsoft had taken action against threats to it. Linux appears in that list of threats by name in a federal court document in 1999. The court gave that barrier a name. It called it the applications barrier to entry. The logic is circular, and it is very hard to break. Users pick the operating system that runs the software they need. Developers write software for the operating system that has the users. Neither side moves first. The loop protects whoever is already inside it. 2 products hold that loop shut for most people, and they have for 30 years. Microsoft Office and Adobe's creative tools. Neither company has ever shipped a Linux version, not because Linux cannot run that class of software, because the market did not justify the port, and the market did not exist partly because the software was missing. That is the distribution describing itself. That is the distribution problem, and it was decided before most of this audience was born. Now, the second reason, and this one Linux chose for itself.
On Windows, a driver compiled years ago still loads today. Microsoft maintains a stable binary interface for drivers and treats breaking it as a failure. Linux makes no such promise, on purpose. The internal interfaces the kernel exposes to drivers change whenever kernel developers decide there is a better way to do something. Nothing is frozen. The reasoning is written down in that file. Greg Crow-Hartman's argument is that a frozen interface locks in early mistakes, forces maintainers to support broken designs forever, and asks unpaid volunteers to do extra work for no benefit. He cites the USB subsystem, which has been reworked at least 3 times to fix deadlocks and improve throughput. Under a frozen interface, none of that could have happened. And his solution is real. Put your driver in the main kernel tree, and when someone changes an interface, they update your driver too, for free, forever. That works. It is why Linux supports an enormous amount of hardware out of the box today, often more than Windows does on the same machine. But it works on one condition. Your driver has to be open source and accepted upstream. If a hardware vendor will not release their driver source, that offer does not apply to them. They now have to rebuild and retest their driver against every new kernel version, indefinitely, for a platform with a small consumer share. Most of them decline. That is the fingerprint reader that does nothing, the webcam that shows a black rectangle, the wireless card that needs a forum thread. The clearest case is graphics. NVIDIA spent close to 2 decades shipping a proprietary driver that lives outside the kernel tree, which meant it had to be rebuilt against each new kernel, and frequently broke when users updated. Linux distributions built entire subsystems whose only job is to recompile that driver automatically every time the kernel changes. That machinery exists because one vendor would not open its source. AMD went the other direction and put its graphics driver in the mainline tree. AMD graphics now work on Linux with no installation step at all. Same hardware category, same kernel policy, 2 opposite outcomes, decided entirely whether the vendor opened the code. One clarification, because this gets misreported constantly. The interface that applications use, the system call interface, is stable and does not break. The same document says so directly and points out that programs built decades ago still run on modern kernels. Only the internal driver interface moves. This is not chaos. It is a specific trade-off. Kernel developers decided that hardware vendors should carry the cost of change rather than kernel maintainers carrying it. For open-source drivers, that decision has been vindicated completely. For closed-source consumer hardware, it moved the cost onto the exact companies least willing to pay it. Now the third reason, and it is the one that kept applications away. A developer shipping software for Windows builds one package. It installs on every Windows machine, and it keeps working for a decade. A developer shipping software for Linux has to answer a list of questions first. Which distribution, which version of the System C library, which packaging format, which desktop environment, which display server. There is no single answer, so the developer either builds and tests several versions or picks one distribution and tells everyone else they are unsupported.
For a small commercial software company looking at a small consumer market, that math never closes. The Linux world knows this and built solutions, applications that bundle their own dependencies and run anywhere. There are now 3 competing systems that do this: Flatpak, Snap, and AppImage. The fix for fragmentation, fragmented. So those are the 3. Distribution locked up by contract before the argument started, a deliberate engineering policy that pushed driver costs onto vendors, and an application target that never stopped moving. None of those is about whether the operating system is good, which brings up the obvious problem with the phrase losing the desktop. Linux runs the majority of web servers. It runs every one of the top 500 supercomputers. It runs on the International Space Station, inside your router, inside your car, and inside roughly 3 billion Android phones. Android is Linux. The kernel is the same kernel. So the question is not why Linux failed, it is why it won every market except one. The answer is that every one of those markets removed at least one of the 3 problems. Nobody buys a supercomputer preloaded from a retail shelf, so the distribution lock does not exist. Server hardware ships drivers upstream, so the ABI policy costs nothing. A company running its own servers targets exactly one configuration, so fragmentation disappears. Android went further. Google controlled the preload, mandated a single application format, and shipped a stable interface for app developers on top of the kernel. All 3 problems solved by controlling the platform. Now the interesting case, because it happened on actual desktop hardware. Valve shipped the Steam Deck running Linux. They controlled what came pre-installed.
They reduced the target to a single fixed configuration, and they spent years and real money funding the compatibility layer that runs Windows software. That last part matters more than the hardware. Valve did not wait for developers to port their games to Linux. They removed the requirement. If the applications barrier holds because the software is not there, one way through it is to run the software that already exists. Thousands of Windows games now run on that device, without a single line of Linux-specific code from their publishers. It worked. It is the first time in the history of consumer computing that Linux got the same conditions Windows had in 1995. Chromebooks tell the same story. Linux kernel, controlled preload, one target, no fragmentation. Millions of them in schools. The pattern is consistent. Linux takes the desktop every time somebody controls the preload and collapses the target to 1. It stalls whenever both of those are left open. So here is the accurate version of what happened. Linux did not lose the desktop on technical merit. It lost a distribution fight that was settled by contract before the technical comparison mattered. Then it made a deliberate engineering decision that has served the kernel extremely well and made consumer hardware support harder than it needed to be. Both of those things are true at the same time. The year of the Linux desktop was never a software milestone waiting to be reached. It was always a distribution problem, and distribution is not something you fix by writing better code. It already happened, twice. It shipped as a phone and as a handheld game console. Nobody called it the year of the Linux desktop because by then nobody was looking at the desktop. Subscribe. Sudo BitLogic is just getting started.